Okay, 8.7 notes is volumes with cross sections, squares, and rectangles. So it says a region is bounded by y is equal to x squared and y is equal to the square root of x and forms the base of a solid. For this solid, each cross section is perpendicular to the x-axis is a square. What is the volume of a solid? So we're still looking at the area, and since we have two functions, we're still taking the top function and subtracting the bottom function. Since it wants us to find the volume of a square, we first have to assume its area. So what's the formula for area of a square? Say that again? No, area. That's parameter. But it's a square. Length squared or s squared. Side squared, right? Because they're all the same size because it's a square. And so s in this case is going to be our top function minus our bottom function. So color coding this. Okay, x squared is here. Square root of x is here. So based on our diagram, which one is the function on top? Square root of x. So this is going to be the square root of x minus x squared. And since this is in terms of x, that means we're looking at the x-axis for our bounds. So it's going to be 1 is at x equals 0, and the other one is where? X equals 1, where those two functions intersect. So I would write this as the integral from 0 to 1 of our area, and our area is s squared. So this is going to be square root of x minus x squared dx. Okay, so again, this section right here is our side, and the area of a square is side squared. So when we take the integration of the area, we find volume. Okay, and that's the idea behind this. So volume of a solid with a known cross-section is going to be the integration from a to b, a of x dx, where a of x is the area of a cross-section perpendicular to the x-axis. Okay, so for these ones, we just have to know how to find the area of squares and rectangles because the notes are about. So for a square cross-section, the volume would be equal to the integration of a to b, s squared dx, the same of how we wrote it in number 1, where s is f of x minus g of x, which is the top minus the bottom function. Then looking at a rectangle, okay, what is the area of a rectangle?
Length times width.
Length times width. Okay, so if we're finding the volume, this is going to be the integration of width. And instead of length, they use the word height. Same thing. Times height dx. Okay. Width is going to be the same as s. So our width is going to be f of x minus g of x, which again is the top function minus the bottom function. And our height is going to be given to us in the problem. So number 2 says using the same base as number 1, which means we're using those same equations in number 1. But the square cross sections are taken perpendicular to the y-axis. So now we're going to have everything in terms of y. Well, in order to do that, we first write the equations down, the original ones. So y is equal to x squared, and y is equal to the square root of x. And then I'm going to get them both where x is isolated. So x is by itself. So on the first one, I would have to get rid of that square by taking the square root. And when I undo a square, I end up having both plus and minus that value. So this is x is equal to plus or minus the square root of y. Okay, for the other one to get x by itself, I have to square both sides, so I get x is equal to y squared. Okay. So again, color coding this to our graph. Okay. We are now looking at perpendicular to the y-axis, so we're going to find our bounds by looking at the y-axis. So our first intersection as y equals 0, and what's our next intersection? Y equals 1. So that means we're doing the integral from 0 to 1. Okay, it's a coincidence that it's the same as perpendicular to the x-axis, just because we are in that first quadrant. Okay, so I would do the integral from 0 to 1. And then remember that one equation of x, when I solved for it, I got plus or minus the square root of y. And that is the green function that I highlighted off to the right. Since we're in the first quadrant, would that be the positive or negative square root of y? Positive. And since that function is on the top, I'm going to do square root of y positive, because it's in the first quadrant. Okay. Minus the bottom function, which is y squared, dy. Okay, for these notes, we're just setting up the problem. We already know that we could solve this integral either by hand or with Desmos, whatever it gives us.
Ms. Marcus,
Yes.
when we do the one that's most like right to the like function that's most to right?
Sorry, say that one more time.
When we like for the first function, when we pick the function that's most to right?
Yes. Mm-hmm.
Oh wait, never mind. Okay.
Well, since we converted everything in terms of y, it's still going to be that way. Mm-hmm. Okay, so number 3 says the base of a solid is bounded by y is equal to x cubed, y is equal to 0, and x equals 2. Find the volume if the cross sections taken perpendicular to the x-axis form a rectangle whose height is 2 times its width. Okay, so I have x cubed, that's this function here. And then I have x equals 2 here. Okay, it wants me to look at a rectangle, which means I'm going to be doing the integration of the area of a rectangle, which is width times height. So first, I'm going to start off by writing that area. Okay, so a of x is equal to the width. And so for the width, we know that we're going to do the function on the top minus the function on the bottom. But on this case, if we're looking at the, well, in this case, the width part, there's not really a function to align it with, because if we're looking here, okay, from 0 to 2, because it's in the x, notice that there's not a function on the top or the bottom. We just have that one function on the top, so we're going to just say that the width is x cubed. Okay, the height, it says in the problem, 2 times the width. So the height is going to be 2x cubed. Well, we could simplify this. X cubed times 2x cubed is 2x to the 6. Okay, I already saw that my bounds is from 0 to 2. So I have the integral from 0 to 2, 2x to the 6 dx. And that was again because when I was looking at the bounds on the x, so the intersection of x equals 0 and then the intersection of x equals 2, I only had that one function to look at, and that was the cubic function. I had no function on the top versus the bottom. Part B says find the volume if the cross sections taken perpendicular to the y-axis form a rectangle whose height is 6. Okay, so in order to do that, first I have to make sure that it is in terms of y, so I have to get x by itself. So I have y is equal to x cubed. So in order to get x by itself, I would take the cube root of both sides. So x is equal to the cube root of y. Okay, since I am looking at the y-axis now, my bounds are going to be from y equals 0 to y equals 8. Yep, it intersects all the way up there. So 0 to 8, that's going to be my integration. And then my area here is going to be my width. Okay, in this case, since I'm looking at terms of y, I'm no longer looking top to bottom, but I'm looking right to left. Okay, so the function that is on the right is that x equals 2, and then the one on the left is the cube root of y. So I'm going to have to do 2 minus the cube root. And then the height is given in the problem. It says the height is 6. So when I do my integral, it's the integral from 0 to 8 of that area, so which is 6 times 2 minus the cube root of y dy. Okay, so again, I'm not solving for any of these because it's not asking me to solve, but notice how all of these examples gave us a graph. Okay, so it's very easy to see the bounds when we're given a graph. Yes? Because when we were looking at, in terms of y, we look at the right function minus the left function. And so the right function is that x equals 2. Left function is the cube root of y. Okay, any other questions before we look at number 4? Okay, so number 4 does not give us a graph, which means in order to find my bounds, I'm going to have to rely on my algebra skills. I'm going to have to set these two equations equal to each other, then move them all to one side so I can have it equal to 0, factor, and then find out what those factors are. So I have x squared minus 4 is equal to 2x minus x squared. I'm going to move the x squared over to the left and then subtract 2x over to the left. So I have 2x squared minus 2x minus 4 equals 0. Okay, I can take out a GCF of 2. And so I have x squared minus x minus 2 equals 0. Which makes this a nice and easy factor that I can factor into x minus 2, x plus 1, and then set each of these factors equal to 0 to find my bound. So I have x is equal to 2 and x is equal to negative 1. And again, these are my bounds. Okay. Once I find my bounds, then I'm going to have to kind of draw a rough sketch of what this graph looks like. Well, I have a positive quadratic here, and I have a negative quadratic here. Okay, so I know if I was to draw a rough sketch off to the side, the negative quadratic is going to look something like this, the positive quadratic something like this. Okay, I need to see that visual because I need to see which function is on the top, okay, and which function is on the bottom. And then I'm looking at this where the cross sections form a square. So I know my area is going to be side squared, and my side is going to be the top function minus the bottom function. So this is going to be the integral from negative 1 to 2. My top function is that negative quadratic, so 2x minus x squared. Okay, minus the bottom function, x squared minus 4, squared dx. Okay, because remember the area of a square is side squared. Function f minus function g is our side, and then we square the whole thing. The only other step you could do is just simplify those parentheses there and combine like terms, and this would give you the integral from -1 to 2 of -2x squared plus 2x plus 4 squared dx. Of course, that's only going to matter on a multiple choice. On an FRQ, you wouldn't even need to integrate this. You could just say that integral is your answer.